the values that are important to us. We know that the amplitude is what?
Negative 1.5.
1.5. Also, very important is we've got no plus on the end. So what does that mean?
That
There's no translation up or down. So that means my curve basically goes above and below the same amount as the x-axis. So it might, this one's not so necessary at the moment, but I'm going to put, for me, a construction line there. Now, because you can't really see it, but you get the idea. That's what I'm calling the centre line, and I put that for whatever the plus c is. So in this case, the plus c is plus 0, so I put it through 0. The next lines I'm going to put are the amplitude. I'm going at 1.5 above and below that line. Okay, so I'm going to put a dotted line. For you guys, you just put a gentle dotted line, nothing hard, but just a gentle construction line. And I'm going to do the same at this point. Alright? And that shows me the maximum and minimum points that I'm going to go to. That makes sense?
yes.
Okay. The next thing I look at is the fact that how many wavelengths are there in 360 degrees, Karen? One. So I'm going to do this. I'm going to put a construction line at my starting value on the axis. I'm going to put another one at 360. Now I only need to do that because I've got to fit one wave in that box, that block. Okay?
Wave means it must be reach its minimum and maximum, right?
Exactly. Yeah, it's got one full wavelength, so I reach maximum, minimum, back to my starting point. Yes?
Since the amplitude is negative 1.5 instead of 1.5, would we start at negative 1.5?
Okay, so that's the thing. So next I look at my cos. So what does a cos graph do? Nick?
It starts at the amplitude,
So it starts at its maximum. Yeah? But because it's negative, it actually starts at
Negative 1.
negative. So now instead of starting up here, it starts here. So I'm going to put my first point there. Now I need to remember what does my cosine do. Yeah? So I need to remember the general approach for my cosine. So great. So I need to remember where it crosses the axis. So that would be
90 degrees.
90 degrees. So I know cosine will go from whatever its maximum minimum and it will head towards the axis and it will cross at 90 and then it will go 180, 270, okay? Now, because I've got it on my grid, I can actually, well, I'm going to do it afterwards, right? So I've got those important points. Now, when I'm sketching a curve, all right, the idea now is to get a reasonable shape. Now, it's hard for me on here, easier for you on paper, but one thing I would say, this is just a sketch, but these points are vital that you get right, because they're easy. And if your curve does not go through exactly those points, you will lose marks, okay? The rest of them, not so much, but we do have to generally get the shape right. So what I'm going to say is this, at these curves, they don't want to be sharp and triangular. So I'm going to get you to actually put a few points, okay, so that we actually get more of a curve. And the same down here, just to kind of get it sort of in the right way, right? So now you see I can go from that point, I can kind of follow that and then go up, make sure I go through that point and then up, and then you see I've got a proper little curve point to go through. Down and round. Okay, so we want more of a curve at those points rather than a sharp point. Now, one thing just to say, when you're doing with a pencil, try and do one single line. It doesn't ever look so good if you're drawing your curve like, so if I'm going to carry on, if I'm doing like that, that's not particularly great. Okay? And it does take a bit of practice to draw these curves.
Sorry, Mr. Brooks. Yeah.
Now that's only up to 360 degrees, but yes, we can now carry it on into the other side, so we can follow it through. We've got negative 90, and then up here, I can see my line. Okay. Alright, so that's one. Done those. So just to check, what is the amplitude of this wave?
Negative 1.5.
Thank you, Kieran. Greg shouted out, but it's actually 1.5, isn't it? The amplitude is 1.5. A is negative 1.5, but the amplitude is 1.5.
Because that's the maximum it reaches?
Remember we said it's not to do with that, it's the difference between the maximum and the minimum. We look at that difference and half it. So it's actually a distance rather than a value on the axis. Great?
You said.
I said indeed. What is the period of this function? Katie?
1.
No. 360, yes. 360 degrees. What you told me was the B parameter, yeah? B is 1, the period is 360 divided by B, which is, the period is actually the length, yeah? The B parameter here, before the X, that is, you are right, 1, but the period itself is 360. Okay? You'll need it again. Alright, let's move on then. Let's have a look at changing something. Okay? We're going to draw y equals sine of 2x plus half. Okay. So this time, I go through it again. Now the first thing I look at is my centre line, plus a half. So where do I put that?
1.5.
Right.
At y equals 0.5.
Exactly. So I'm going to put a construction line, again, put the line, okay, at that point. Why can't you just use a normal ruler? Why do you have to be a cat?
No, it's more accurate.
No, it's not.
It's not. It's not in any way more accurate than normal.
Are you?
You're just disrupting those people around.
Are you using? No, he's not. He's not disrupting.
Yes, he is using a yardstick. Or
Mr.
something.
Potts, he's not disrupting.
He is. He's just disrupted both of you. You might not care, but you have been disrupted.
YouTube. I'm sorry, Mom, if you're watching this.
Right. Use appropriate tools for the job.
Thank you.
Okay, so we've got our centre line. Now this is where it's important. So what is the amplitude? Ethan?
1.
1. So
So
where do I draw my lines?
1.5?
Exactly. So 1.5 is the maximum it goes up to. And the minimum it goes to is? 0.
Negative 0.
Negative 0.5. There you go. Now, one thing I will say to you to do is, because this centre line now becomes sort of my axis, I put my marks, okay, on them, because I don't want to be looking at the x-axis values, because those values have all been shifted up. So, here's the next thing then. I now look at the fact that I've got 2x. So what does that mean, Nick?
You have two full wavelengths within 360.
Okay, so, Greg?
Yeah, the frequency is 2.
Okay, so this is how I would do my construction then. So remember I just made one box to draw in last time? Well, this time what I do is one thing. Yeah,
Make cookie grab water and it's a little too strong.
you took them in.
Drinking water will make it worse.
It will, it'll make it a lot better.
Well, actually,
Yeah.
Yeah, like you've never had a minute to drink water.
It's
like drinking water out of
We're recording, by the way.
Nick, it's like drinking water out of toothpaste.
Right, come on then. So what we try and do is guys, Nick. So I'm going to put my line at 360 like I did before, but I'm also going to cut it in half at 180. And that's because I've now got to fit 2 curves in that. So I draw my boxes so that it works. Alright? So,
I get everything else except why are there like 3 lines? Why is it only at 0.5?
because that's the plus a half bit. So my whole graph gets shifted up. Maybe you'll see in a second. Okay? So I'm now kind of ignoring the x-axis. It's even there. Alright? So I've shifted these marks up. Now, what do you know about the final thing, which is a sine curve? What does it do? Kieran?
it crosses
It doesn't. Well, it does when it's only a sine curve, but in this case it doesn't. It crosses at
0.5.
0.5. So here's my starting value on the centre line. And Greg, what do I know now?
Now, we need to draw another thing at 180 degrees and one at 360.
Okay, so this is where my knowledge of a sine curve comes in. So I know it goes up to a maximum and then down to a minimum. It's not a negative. But I've got to now split. So in 360, I use the same thing, 90, 180, 270, 360, as I did with the previous one. But now, because I've got to fit 2 in, I've got to kind of split the boxes again. So I'm going to actually split it. I need 45 and I need 135 marked off. Alright? So then, for instance, I can go above that. That's where it reaches the maximum value. Alright, so my curve will go up. Remember trying to do a bit of a curve at the top. It will then come back down in the middle.
There we go.
It will come back down there. Okay. Excuse me for mine. At 90, it will reach minimum. We'll go back up.
No.
Yeah, sorry, you're right. I'm being confused by the fact that it's possible. So it goes through there, and yes, it goes down to that point, minimum, and then halfway. Is that right?
Yeah, and then it goes to that 135.
Sorry, mine all shifted. Let me start again. Alright, so I go above, that's better. So now I come back down, 390, down to that, and it should finish. Sorry about the little scribble at the end there. Yours will look much better. And I've done one wavelength in the first box. Now I've got to do another one. So again, put up my maximum back to middle, down to minimum, back up. So I've now drawn I think I did too bad, but that's not very good. Okay,
Oh, I see.
so I've got my 2 wavelengths done in 360 degrees.
So like this. It actually helps to do like sketchy lines, and then once you're done, like
Mr. Potts?
Yeah.
Would you see at the very start on 0.5? Would you do that curve going
No.
up since?
Yeah, it shouldn't be curved, should it? It should go straight through. So again, this side needs to go minimum, centre, maximum, back down. Now, you might think we're going a bit over the top with the sketch lines and things. We don't need them, but you would believe how they really do help. And people that don't bother, their curves just end up getting narrower or getting wider. And then, to be honest, it's just wrong. It's the wrong curve. So I know my curves don't look great. They have been better in the past, but at least they kind of generally show the correct way of it.
So it goes through 270 0.5?
Yes.
Okay,
so just go through it quickly. We've got +1 centre line, so there's my first line. +1 centre line. Make sure we mark off 360.
That is terrible.
Amplitude is 2, so I'm going to go 2 above the centre line.
Mr. Potts?
Hang on. 2 below the centre line. Now we know sine starts on my centre line. Okay? And then because it's a negative, it goes down instead of up. And we've only got half a wave in this 360. So instead of having one that does all of that, we only have this part has to spread. So the minimum will be down at this point, and then it comes back up. So that will be my curve. Okay. Yes, Greg.
So it doesn't have to intersect at 0 doesn't have to intersect at 90, right? Because that doesn't make sense. So when it intersects x-axis,
Yeah.
it doesn't have to be at 90 or 270.
No, because it intersects the centre line of those values. That's why I said the important thing is to put the centre lines in.
Yes.
Okay? So your curve on your screen actually, if we extend it through the whole thing, looks like that. Okay. I think you got that? Easy enough?
Yes.
Well, what I was actually going to do, we've got this one now.
That's another one. This graph is insinuating that it's going to be very unique.
Okay, so this one, all right, this one's from, this is the set of axes from the textbook, and it's from an applied problem. All right, so I just wanted to show you how the fact that the numbers don't necessarily have to be the small numbers like that, okay? And when we apply these curves and situations, the numbers can change. Okay. So, what we've got is this. So let me tell you the curve to draw, all right? And then you have to try and figure out the equation. So, basically, because it's an applied situation, it says a nail is stuck in a car tire. Okay? And what will then happen? Air will leak.
No.
Well, let's say the air doesn't come out because the nail's still in the hole, which is quite often what happens.
The nail will will rotate with the tire and then create like a sine or cosine wave.
Exactly. So we've got this cyclic movement of the nail. So if we measure, or if we consider the height of the nail, okay, at any given time, or at any given distance of travel, okay, and this is distance in centimetres.
It can never be negative, right?
So exactly, so you'll notice how my graph now has much bigger numbers, right? And there is no negative, because height is not going to be a negative. So,
What would height be in centimeters also?
doesn't actually say, but yes, I think the height would have to be in centimetres. Doesn't say on their grid. Right. So, basically the curve follows this pattern. So I'm going to give you some points and you're going to plot them. Then you're going to do the curve and then you're going to find the function for it. So obviously, we kind of start there. And what does that mean the nail's doing?
It was at the bottom of the tire.
It was at the very bottom of the tire. Does that make sense?
Yeah.
Why?
Because a nail can't just be floating.
At what point are we
Because,
starting
like,
to measure them from?
Oh,
The
when
nail's
the-
going to be on the
On
ground,
the nail,
obviously.
like,
It's going to get stuck in
impales
the
the
ground.
tire.
That's it, isn't it? It starts at that point on the ground. It's not halfway round the wheel because when the nail goes into the tyre, it must be
Underneath it.
underneath the tyre. Okay.
Unless it's sabotaged and the nail.
Yeah. Somebody stabbed the tire.
Okay. The car is moving, so it immediately travels, right? So after 90 centimetres, it goes up to its maximum, and its maximum is at 60. Okay?
Is that a big tire?
I would imagine so, yeah, because it's a no.
70 centimetres? No, it's normal.
Isn't 100 centimeters a meter? Or no?
Yeah. 100 centimeters.
Tractor?
So that's
Truck.
like it's like over half a meter.
It does say.
Oh yeah, meter isn't tall. Sorry, never mind.
I mean, yeah, you were just using it on your desk. Okay? So that's the minimum height on the ground. That's the maximum height because that's when the wheel has done half a revolution. Okay? So,
Oh, there's nothing about that.
is that 90? Okay. You now can continue that graph yourself, knowing only those two pieces of information and the fact that it's in the car tyre.
Yes.
All right. As the car travels for 540 centimetres.
That's only 5 meters.
Because obviously it was a fast deflate of the tyre and you notice straight away. So he only goes 5.4 metres. But you can carry on that curve assuming no deflation of the tyre, no change in height, and then you're going to figure out
Okay.
the function.
I was gonna say when the maximum change of the tires is deflating.
Got it? So you should be able to carry that graph just from those 2 points.
Oh,
Right.
that was a tricksy Dixie because it starts at 0, 0, so you think it's. Oh.
We know minimum, maximum, minimum, maximum, minimum, maximum, minimum. Is that right?
We'll be racing.
Is that right?
So it looks like a zigzag.
Okay, so your curve should look like so this. So sorry for my sharp pyramid triangle type thing, which is just rubbish. That's awful. Anyway, so what we've got then, we need to identify the maximum, the minimum, halfway through. Okay. Halfway through is at 30. We go to 60, we go to 0, so the amplitude is 30.
Negative.
Okay.
Well, you have to.
I'm just writing 30 for the moment. Okay. My curve starts at sorry, the centre line is 30 at the start of 30. The centre line is 30, so I need a plus 30 on the end. Okay. It is not a sine curve, it is a cosine curve because it doesn't start there, so I know it must be cos. How many wavelengths are there in 360?
There are 2 wavelengths in 3.
There are 1, 2 in 360, so it must be 2x, and cosine normally starts up there, so this one starts down there, so it must be
Negative.
negative. So we've got y equals negative. Yes, Greg?
So, since it seems so, the number to the left of cosine is a, right, which represents the amplitude.
Yes.
But it also represents where it starts. So, because if I said that the amplitude was negative 30, that wouldn't be correct, would it? Or,
No.
so would it be better to put like negative 30 and then absolute value sign?
We don't need to. No, because that would change the function. That would be that wrong. That function would never be negative.
Negative. Okay.
Before you go anyway, guys, I've got like my second bell hasn't gone yet.
Pizza back.
I don't care about pizza. Final question. The longer it takes me to get there, you chat, you lose time. Quick question. What's the period?
How many?
Not degrees, but how?
It's 108. It's
180. And the distance of?
full revolution.
And therefore that is the what of the wheel.
It's a wavelength. This is the wavelength. One wavelength.
Height.
Like,
Circumference of the tire.
Circumference.
Yes!
What is the radius of the wheel?
Well, it's divided by pi.
Which is?
30.
30. Radius of the tire is 30. Okay.
second bell.
Yeah, it's coming. I heard the pre-bell.
I heard the pre-bell.
Enjoy your pizza.
It's a little, like when you hang up about